Okay, so here's what we got today. Today we're going to talk about graphing exponential functions. So take a look at the example that we did in class. So what we have here is we have an example of an exponential function. It is, if we zoom in, y equals 2 to the x, y equals 2 to the x. So if you actually go ahead and you use your calculator on this, I know we're not necessarily going to, I'm going to show you some stuff where we're not going to lean heavy on the calculator, but I want to show you again the calculator. So if we want to figure it out, when we do y equals 2 to the x, when we do y equals 2 to the 2, 2 to the 2, 2 squared is 4. Y equals 2 to the 1, which is 2. Y equals 2 to the 0, which is 1. Y equals 2 to the negative 1, which according to that sheet I gave you is 1/2. Y equals 2 to the negative 2. That's 1/4. Y equals 2 to the negative 3. That's 1/8. Y equals 2 to the negative 4th. That's 1/16. And then y equals 2 to the negative 5th. That's going to be 1/32. Now, if you look at those numbers, we are getting progressively smaller. Actually, we're getting half as big. 4 to 2 to 1. To 1/2 to 1/4 to 1/8 to 1/16 to 1/32. And if you actually think about that, what is actually happening there is that that thing is getting closer and closer to 0. Is what's happening as my x is getting really, really small, which is what's happening. My x is getting really, really small. This number is going to keep getting progressively smaller, 1/64 to 1/128, and those numbers get really, really close to 0. So for exponentials, let's just talk about some of the things on exponentials. On exponentials, the domain is always going to be all real numbers because we can put in any number for x. Now our range is going to be kind of unique here in this case because our range is basically going to be what values can y take. And if we actually look at this, when we go to 1, 2, 1, 2, 3, 4, so there is 2, 4. There is 1, 2. There is 0, 1. There is negative 1, 1/2. And you're going to notice these things are going to get progressively smaller. What ends up happening here is that your exponential is going to look like this. And what you're going to notice is the y values are always going to be greater than 0. So in this case, what it's going to be is going to be y is greater than 0, or if we write it in interval notation, 0 to infinity. Now the 2 points, I'm going to tell you honestly, 2 points whenever you do this, the 2 points are going to be when you raise it to the first, and when you raise it to the 0 is typically where you have your 2 points. So the 2 points I have here are 1, 2, and 0, 1. And what we're going to find out is that when we talk with a base exponential model, all of them are going to have this one right here is going to be the y-intercept. Now horizontal asymptote. What I'm going to tell you again, when we do horizontal asymptote on this, horizontal asymptote is always going to be in this case to start with, is always going to be that x-axis. So it's going to be y equals 0 is my horizontal asymptote. When we look here, exponential, our choices are either growth or decay. And as we notice when we read this thing, it's going up. So this is exponential growth because f of x is increasing. So that's our first one. This is an example of exponential growth. Exponential growth. Okay. Now we'll take the next example. Next example, we're going to deal with a fraction. So again, I'm going to kind of walk you through this. When we actually do the negative, remember, negative takes a reciprocal. So if I was doing y equals 1/3 to the negative 2, what that's telling me is I have to flip the fraction, make it positive. So that's 3/2 to the 9th, or 3 to the 2nd. So that'd be 9th. When I do negative 1, it's actually going to flip it over. This makes this 3. Anything to the 0 power, 1/3 to the 0 power is going to be 1. 1/3, so 1, 1/3. And as we go along, what we're going to see is that the second power is 1/9, 1/27, 1/81st, 243rd. So again, look at your table. This will give you those values. So you don't have to memorize them or anything else. So what we're noticing is X is getting larger. What we notice is as X gets larger, as X goes this way, Y is actually approaching 0 as well. So what I'm saying is as X goes this way, notice my values again are getting lower and lower. So again, if we plot this, -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, -2, 9, -1, 3, 0, 1. Hey, look, there's that 0, 1 again. We have 1, 1/3, and we keep going down this way. And what we're going to see is with this, what happens is this one right here is an example of what's called exponential decay, because it's going down. But again, the domain, again, all real numbers, or in interval notation. The range, again, it's always going to be positive, so it's 0 to infinity. 2 points. In this case, 0, 1 is going to be one of my points. That y-intercept is the same. What I want to do is I want to pick one other one. And in this case, the one is not tremendous, but you could use it. I would probably use -1, 3 because it gives me integers. And as you notice, horizontal asymptote, again, is going to be that y equals 0. This graph shows exponential decay because f of x is decreasing as we reach the right. So in this case, so just as a summary, all basic exponential graphs have a horizontal asymptote at y equals 0. All basic exponential graphs have the order pair 0, 1. 0, 1, that's our y-intercept. If b is greater than 1, then a second point is going to be increasing. So it's going to be going up. If b is between 0 and 1, the second point is going to be decreasing. So the way to remember it is this. When you have an exponential function, when you have y equals b to the x, that number right there is going to tell you whether it's growth or decay. If b is greater than 1, you have growth. If b is between 0 and 1, you have decay. So that's the example of the notes we did for today. You can do other things with it that we actually talked about in class, but that's the basics of it. I suggest you practice what we did in class. This is going to be one of those ones where we're not going to use calculator or Desmos. We're just going to use the basics. That table is going to get us a long way there. So please ask me if you have any questions. Give me feedback in the reflection, and we'll be moving on to logs in the next class.